A silent void is driving most events in the cosmos. Not stars, not galaxies, space itself is doing the heavy lifting. The immediate takeaway is simple: emptiness behaves like an engine. Picture a dark gulf between galaxies stretching for millions of light years. It looks dead, yet it never sits perfectly still. Fields ripple there, gravity flexes there, expansion accelerates there. When you zoom out, almost everything happens because of that background. When you zoom in, tiny jitters keep nudging matter into motion. This video shows how that nothing powers the universe's big stories. From quantum flickers to cosmic acceleration, space keeps pushing outcomes. We will keep things clear, grounded, and packed with real examples. By the end, void will feel like the universe's engine. Start on a lab bench with two polished metal plates. They sit micrometers apart, aligned so their faces mirror perfectly. Even in a vacuum chamber, a tiny force pulls them together. That tug is real, and it comes from empty space. Vacuum in physics means the lowest energy state of fields. Those fields never go flat because uncertainty forbids perfect stillness. They jitter, borrowing energy briefly, then paying it back fast. Between plates, fewer jitters fit, so pressure outside wins. We call it the Casimir effect, and it is measurable. Experiments report piconewton forces across micron-sized areas. Atoms feel this background too, shifting energy levels slightly. That shift, called the Lamb shift, matches quantum vacuum predictions. So emptiness is a restless sea of fields, not nothing. Tiny test, turn off all particles, the sea keeps sloshing. Bottom line, the quiet background is active at every scale. Now step far outside, where galaxies drift like lanterns in surf. Their motion is speeding up, not slowing down under gravity. That surprise revealed dark energy, energy packed into space itself. Dark energy means space has a nearly constant energy density. As more space appears, total energy grows and expansion accelerates. Pressure turns negative, so gravity responds by pushing things apart. This behavior fits an equation where W sits near -1. Why care beyond the math and the symbols? Because this sets our cosmic future and our present composition. Today, dark energy fills about 68% of everything. Matter, both dark and atomic, shares the remaining third. How do we know without simply guessing or hoping? Type Ia supernovae arrived faint, signaling faster expansion over time. Galaxy clustering and the microwave background sketch the same picture. One sentence recap: space makes more space, and the push snowballs. So the picture is, the vacuum's bookkeeping drives cosmic acceleration. That is activity, not emptiness, shaping the largest possible scale. Rewind to a split second after the beginning, when everything changed. Space ballooned faster than light, smoothing wrinkles and stretching ripples. That burst is called cosmic inflation, a runaway of vacuum energy. Inflation explains why distant regions share the same smooth temperature. It also explains where galaxies got their first tiny seeds. Quantum jitters in the field were blown to astronomical sizes. They froze as imprints, later guiding gas into filaments and clusters. We test this by reading patterns in the microwave sky. Temperature bumps sit around 10 to the -5 relative. Sound waves in early plasma leave peaks at specific angular scales. Planck mapped those peaks precisely, and the shapes match predictions. The spectrum is nearly scale invariant, with a slight red tilt. That tilt says larger ripples were favored, but only slightly. Quick image: ripples on a pond, suddenly frozen as the wind stops. Later, gravity amplifies them, building webs where galaxies will gather. Net result: space's early sprint wrote the blueprint for structure. Activity here meant expansion speed, translating quantum noise into architecture. Shift near a black hole, where the horizon hugs dark space. Quantum fields there behave strangely, and they can leak heat. Hawking showed horizons radiate, slowly bleeding a black hole's mass. Pairs form near the edge, and one escapes with energy. To distant eyes, the hole glows faintly with a temperature. For a solar mass hole, that temperature is absurdly tiny. It sits around 60 nanokelvin, colder than deep space. Evaporation would take about 10 to the power of 67 years. Remove the hole, keep the acceleration, and space still warms. The Unruh effect says accelerated observers see a thermal bath. Push hard enough and vacuum feels like a low oven. At 10 to the 20 meters per second squared, it's 4 Kelvin. These numbers are small, yet the principle is enormous. Space defines temperature and light when horizons or accelerations appear. Bottom line: geometry and motion turn vacuum into a radiator. Now zoom into an atom where electrons dance around a nucleus. Even here, the vacuum sea of pairs hovers around charges. Positive charges attract a veil of negative pairs, screening strength. Pull the microscope closer and the veil thins, revealing more. That change with scale is called running of couplings. Electromagnetism grows slightly stronger at shorter distances, higher energies. The strong force does the opposite, letting quarks roam at speed. These shifts are not philosophy, they steer real measurements. Hydrogen's Lamb shift lands near 1057 MHz. Electron magnetic moment matches theory to parts in a trillion. Collider events match predictions only after including vacuum polarization loops. Rule of thumb, fields talk to themselves through flickering virtual pairs. That talking edits forces, chemistry, and the lives of stars. Remove that chatter, and the periodic table looks different, so the quiet background keeps rewriting the rules as you zoom. Step into a merger where two black holes spiral toward doom. They twist spacetime, sending ripples racing across the universe. Those ripples are gravitational waves, and they carry real energy. They squeeze space one direction, then stretch it the other. Detectors watch mirror distances wobble by 1,000th proton width. That wobble is a strain near 1 × 10⁻21. LIGO caught such a tremor in 2015. About 3 solar masses turned to waves in 0.2 seconds. That energy is about 10 to the power of 47 joules. Space was the messenger, and also the moving thing itself. No medium carried it, spacetime changed shape and transported energy. We now map colliding stars, measure speed, and test gravity. The map keeps growing, revealing neutron star fireworks and kilonovae. One sentence recap: space flexes, rings, and ships power across void. That is activity you can hear if you translate it. Back on Earth, engineers learned to shake light out of vacuum. They used a superconducting circuit acting like a moving mirror. By modulating boundary conditions, random modes turned into real photons. This is the dynamical Casimir effect, verified in 2011. Pairs of microwave photons appeared, with matching frequencies and phases. Energy came from the drive, but the seeds came from vacuum. Other labs built horizons in cold atom clouds and water tanks. Bose-Einstein condensates grew regions that trapped sound like light. Correlated phonons popped out, mimicking Hawking's thermal spectrum. Water channels produced ripples resembling horizons and surface waves. These analogs are not perfect, yet they test hard ideas. They show how geometry and motion feed energy into quanta. Tiny tests wiggle boundaries fast and watch darkness flash light. Engineers eye sensors, amplifiers, and quantum networks built on this. Recap: we can coax nothing into something when conditions align. So what does most of the universe's work honestly measured? Ask 5 questions and tally which component moves the needle. Who dominates the energy budget today across cosmic scales? Space wins with dark energy near 68%. Who set the initial blueprint for galaxies and clusters? Space wins by inflating quantum jitters into seed patterns. Who decides the long-term fate of distant galaxies? Space wins by accelerating them beyond each other's horizons. Who whispers inside atoms, editing forces and spectral lines? Space wins through screening, loops, and running couplings. Who carries titanic energy across billions of light years? Space wins by sending gravitational waves that ring detectors. The claim is bold, yet the receipts are measurable. Matter shines, forms life, and builds planets, but rides the background. The background supplies energy, structure, signals, and future trending. Bottom line, space behaves like the real engine of change. We began with a claim that emptiness drives the big stories. Now you have the receipts, from plate forces to cosmic acceleration. If that flipped how you see space, stick around. I dig into ideas that feel wild yet testable. Next time we could chase how time itself gets braided. For now, let the void feel busy, not blank. Thanks for watching, and consider subscribing if this sparked curiosity. Your curiosity keeps these deep dives clear, grounded, and fun. Final recap: space is quiet, but it never stops working.